If you guys don't, okay, I'm recording. Okay, let me go back to the slide again, really quick. So again, thank you fourth period for being the test subject for our recording video for today. And let's go back to the presentation really quick. So, right, what make a fair experiment? So we did the respond, and then we are looking at the scientific practice diagram. So again, scientific practice diagram really quick. So observation, question, hypothesis, right? People like to start from observation, but we know that in a scientific practice, it's an infinity, right? It's a cycle. You can start at any point. If you're a professional scientist, you can always start with data, right? Because that's your job. But most people will start observation because they catch their attention, and then they create a question, and they make a prediction, or what we call nowadays inference, right? What we learn. And then you develop an investigation, collect data, refine it, and hopefully you have enough data to become a theory. Observe things, right? We create an inference or a hypothesis. We talked about the other day. Now we need to create an investigation. And what make an investigation fair, right? That's our goal. That's why we started with that question. What make an investigation fair? What make an investigation fair is that you know how to answer these variables. What are the three variables that you need to focus on? Again, this is something difficult, okay? I'm not saying this is easy. It will take a while, it will take practice for you to slowly understand it better. So if you don't get it the first time, don't feel like, you know what, I'm gonna give up. No, practice, practice, practice. It's kind of like playing sport. What are the three variables that I need to know when I create an investigation? The first, what we call independent variable. Independent variable, what does it mean? It means the one and the only factor that is changed in an experiment. So technically I can say the key word for independent variable is AKA, also known as change. This is something that changed in my investigation, and I call that independent variable. Okay, so remember that. Independent variable means change. That's what you need to remember. And then I also have dependent variable. Dependent variable is the factor which is measured or observed in an experiment. It responds to the change in the independent variable. AKA dependent variable means measure and observe. What I measure and observe, or the data I collect. Make sense? And that's the definition of dependent variable. The data that I collect. How do I collect the data? That'll be dependent variable. And then the last thing is control variable. It means that the factor that stay the same in an experiment. Thing that I keep the same in an experiment. For example, if I test to see brushing teeth every day or not brushing teeth will have an effect with me and my friends, my control variable would be, is the same me, right? And brushing teeth or no brushing teeth is the same me. Maybe I go to the same location for both tests. Maybe I wear the same clothes, because sometimes if you wear different clothes one day and another day you wear it might change that result. So I want to keep it the same. So what control variable means? Things that stay the same. Okay, so let's review this really quick. Independent variable, aka change, thing that's changed. That's different in that experiment or investigation. By the way, you're gonna start hearing people use the word investigation more than experiment, because investigation is a new way of the scientific practice they use, because they sound better, like you investigating, but they technically the same. Okay. Dependent variable is what I measure or observe, and control variable are the things that stay the same in the experiment. Make sense? So let's test you guys out. Okay. Let's say I imagine you want to see what color a bird feeder your local bird prefer. So let's say I observe the bird feeding on a bird feeder, and I wonder, my question is, hey, does the color of a bird feeder matters? Does it change the amount of food a bird would come and eat or not. And so that's my investigation. Okay. So that means I have a bird feeder that's red, blue, and green. I want to know, hey, what color would the bird prefer? Okay. And how would I know that? Well, then I can kind of like check to see the amount of food that they eat. So everybody, I'm going to give you 3 minutes based on this investigation right here, right? This experiment that I'm trying to create right here. Identify independent variable, which is AKA change, something that's different. Dependent variable, AKA what I measure or observe. And control variable is the thing that stays the same in that experiment. So go ahead, take 3 minutes. Okay, 3 minutes. Respond. Let me know what would be the independent variable, dependent variable, and control variable for that experiment. Go ahead. Okay. All right. So independent variable again mean change, right? In this example, what is the change? What different in this experiment? And that'll be the colors of the feeder. So you set the color of the feeder. Good job. Give your cell a pat on the back. That'll be the color of the feeder, right? That is something I change. Okay, that's something different. And then dependent variable is what I measure or what do I observe to collect as my data. How do I know if it worked or not? Well, how do I know if it worked or not? Is the amount of seed or food that the bird eat, right? So dependent variable is the data that I collect. And in this case, I collect the data of the amount of food the bird eat. And that's how I know which bird feeder color do they prefer, right? And that's my dependent variable. And then the last thing is control variable, things that stay the same. In this case, the location of the feeder, right? You want to hang them in the same location. You want to keep everything, remember in a good experiment, you want to keep everything the same except for one different. And in this case, the only difference is the color of the feeder. You want to feed them the same food, right? Because you don't want one food is better than the other, right? Putting the feeder out at the same time, you want to introduce at the same time. So that way it's fair. And that is independent variable, dependent variable, and control variable. So when you create any experiment, those are the 3 things that you need to identify. Like same thing with here. Okay. If everything stay the same except the independent variable, which is held constant, we can say the experiment is fair. What do I mean by that? That means if everything stay the same except for one factor that is different, and that factor that's different is what we call independent variable, we say the experiment is fair. That means it's a good experiment. That means it's a good investigation, right? So you guys should remember, right? Only the independent variable can change. Only one thing can change. Everything else should stay the same for the experiment to be fair. Okay. How come? Well, everybody look at this one. Everybody's respond for me for this one. Is Sam experiment fair? So let's say Sam, a student, create this experiment of the different color bird feeder. All right, but he hang the red feeder at a dead tree. He hang the blue one at a dog house, on top of the dog house. He hang the green one on top of a tree with a lot of leaf and branches. So tell me, is this experiment fair or not fair? Okay, so go ahead, go and vote. All right, there you go. All right, so you have not voted, please vote, okay? All right, so most of you guys said it is not fair. It's not a good experiment. So everybody go to the Google group chat. In that box, can you tell me why is it not fair? And you're right, it is not a fair or good experiment. How come? How come it's not a fair or good experiment? So tell me, why is this not a fair or good experiment or investigation? In different places, different location, apply. So we all agree this is not a fair experiment, and you are right. is because now you have two factors that you're changing. You are looking at different color feeder, and you're also looking at different settings, right? Now, let's say the bird come and eat more seed from the blue bird feeder here. Now, are we sure that is it because of the blue feeder that the bird prefer, or is it because of the on top of the dog house that the bird prefer? We wouldn't know that because now you have two independent variable, and that is not a good experiment, right? Because now you don't know which one is the result, is the cause of the effect. So how do they change this experiment? Well, then they need to put the red bird feeder on top of the house as well, the green bird feeder on top of the house as well. So that way now you will know that which color will be the better one. Make sense? So that's important when you create an experiment or investigation, is to keep everything the same except for one independent variable, one different. Okay, moving on. Why is it important to change only one thing at a time? Well, we said it. If you don't do it, then you won't know what is causing the result, right? If you have too many independent variables, too many changes, then you wouldn't know what is the reason, right? So you want to keep only one. So keep that in mind, okay? Because you guys are going to be good scientists, so you know how to do science. There's two more experiments I want you guys to answer for me. All right, let's read it together. Farmer Bob wants to test his new fertilizer to help his crops grow better. He sectioned off two large areas of his field. In section A, he watered his crop as usual but adds no fertilizer. In section B, he watered his crop as usual and also adds his experimental fertilizer. After one growing season, he records the growth of the crops. So again, make sure you answer them. Let's move on. So what is the answer? Well, here's the answer, right? I mean, if you look ahead of the note, you know the answer, but I wanted you to challenge yourself. So the control group in this case is the group that stays the same, the one that is normal, okay? And the one that's normal is the section A, right? Because section A, normally people don't use fertilizer to grow crops, right? And then that means the experimental group, the section that he's testing out is section B. And section B, because that's the one that he'll be using the fertilizer. So then what is the change? What is the independent variable, aka change between control and experimental? That'll be the chemical that he added, or you can just say fertilizer that he added. And then the last thing is the dependent variable. What is the key word for dependent variable again? Is what he collect, what data does he collect? What does he measure or grow? Right? I mean, what he measure or observe, my bad. And they specifically told you right here, he record the growth of the crops. Make sense? So some of you guys, I noticed you guys still missing the